Okay, sometimes when you solve these log equations, you're going to get more answers than you need. They might have an extraneous solution. So, first and foremost, if we have multiple log terms, we must first condense them into a single log term. If you recall, log base b of u plus log base b of v is equal to log base b of u times v. So I got to take this 5x and multiply it times this x minus 5. So I'm going to say log of 5x times x minus 1. We've condensed the two log terms into a single log term. Okay? Now, we can, starting with the base of the log, rewrite this in exponential form. So starting with 10, I can raise it to the opposite side and set it equal to what I'm taking the log of, which is 5x times x minus 1. You're going to quickly realize that this equation changes into a quadratic equation. Once you distribute this 5x, you're going to get 5x squared minus 5x and 100 on the far left-hand side. Writing this in standard form allows you to subtract 100 from both sides and get 5x squared minus 5x minus 100. If you recognize the greatest common factor of 5, divide it away. Divide it away. So 0 equals x squared minus x minus 20. Now you're in a position of solving a quadratic equation in any of the ways that are allowed. Quadratic formula, solve by factoring, solve by completing the square. Personally, I always try to solve by factoring first. If that doesn't work, then I use the quadratic formula. In this case, you're going to notice right away that if you go 1 times negative 20 and copy the middle coefficient on the bottom, we can use 4 and negative 5. Their product is negative 20, but their sum is negative 1. So you've got x plus 4 and x minus 5 as your factors. The zero product property says if this times that equals 0, then one of them must be 0. So let's say that x plus 4 is equal to 0. Or let's say that x minus 5 is equal to 0. One of them must be 0. We just don't know which. This produces two answers showing that x equals negative 4 or x equals positive 5. The question is, which one is extraneous? To figure that out, you've got to plug it back in. If you substitute 5 back into the original problem, here's what you're looking at. 5 times 5 is 25. 5 minus 1 is 4. Okay? If you condense this, you're going to have 25 times 4, which is 100. Log of 100 equals 2 is true because 2 is the exponent you place on 10 to get 100. So x equals 5 is actually a solution to the problem. When you substitute negative 4, you get log of negative 20. You cannot take the log of a negative number. For this reason, it violates the domain and is called extraneous. The domain restriction on logarithms, or I should say the domain of logarithms, is x is greater than 0. So if you're trying to take the log of a negative number, that can't be, so you stop and you call it extraneous.